You are welcome to SK Pass International College. I would like you to subscribe to the channel, like the video, and share to your colleagues. We are still on the topic hybridization. Okay, so hybridization and bonding. We have discussed a lot about hybridization already. So if you have not watched my previous video, I will plead with you to kindly watch and subscribe to the channel. Now, in our previous video, we have studied about the definition of hybridization to be the mixing of two or more atomic orbitals with different energies and shape to form new orbitals with an equivalent energy and shape. We have also discussed all the types of hybridization, talking about the SP, the various types. We discussed about SP, SP2, SP3, SP3D hybridization. We also discussed about SP3D2 hybridization. So if you haven't watched the previous video, kindly watch, subscribe and share. If you have any question, you can comment at the comment section. But in today's lesson, we are basically going to study about a type of covalent bond or the types of covalent bond in this hybridization. We said in our previous video that hybridization normally occurs in covalent molecules, but it is not all the covalent molecules that this type of hybridization occurs in. So we are going to look at some covalent molecules that this hybridization occurs in. Now, our study is going to be based on sigma bonds. Sigma and pi bonds. Now, for you to get this concept very well, you need to understand what we refer to as VBT. Simply, it implies or it stands for valence bond theory or valence bond theory. So when you pick the valence bond theory, we are going to discuss everything concerning this theory, and that will help us to understand the various types of covalent molecules or types of covalent bonds in hybridization. There are two main, and that is what we call sigma and pi bonds. So let's look at how these bonds are formed. We said that the s orbital is spherical in shape. So this is the shape of the s orbital. So this is the s orbital. Now, anytime I have an s orbital mixing with an x orbital, there is a new species formed. So look at this. I mix this x with another x orbital. Then in this case, it means I'll form, this is an s orbital and this is another s orbital. These two orbitals have been able to meet to form a bond which we refer to as a sigma bond. So in this case, we can see that in this sigma bond formation, it has been formed as a result of the head-on. So let's assume this is one and this is another one. It has been formed as the head-on overlap of these atomic orbitals, the SS orbital. Or someone will say it has been formed as the axial or the head-on overlap of this S and this S orbital. So this is a condition for sigma bond to be formed. It can be formed between an S orbital and another S orbital. So the bond formed here is what we refer to as a sigma bond. Now, we can also have another formation through when I have S orbital mixing with a p orbital. we said that the p orbital is dumbbell in shape. So this is the shape of the p orbital. So in this case, when you mix this s orbital with this p orbital, we form this overlap. So you realize that there have been another head-on overlap of this orbital. So we have the s orbital mixing with the p orbital. So sp orbital. In this case, the bond formed here is what we refer to as a sigma bond. So sigma bond can be formed as a result of the head-on overlap of ss orbital, a head-on overlap, or an axial overlap of an s and a p orbital. Another condition for sigma bonds to be formed, it can also be formed when we have, let's say, a p orbital mixing with another p orbital. So in this case, we have one p orbital mixing with another p orbital. So you can see the bond formed here, the head-on overlap formed here becomes our sigma bond. So this is another condition. So with this first condition, it was formed as a result of an ss orbital mixing or forming a head-on overlap. This is formed as a result of an s orbital mixing with a p orbital to form a sigma bond. And they are formed as a result of the head-on overlaps. Now, in this case, it has been formed as a result of mixing p orbital with another p orbital. Either it will be like this to form a head-on overlap, or they can still be formed like this. In this case, there is a formation of a head-on overlap like this. So when I mix two p orbitals, I'm able to form a sigma bond. When I mix s and s orbital, I'm able to form a sigma bond. When I mix s and a p orbital, I'm able to form a sigma bond. When I mix p and a p orbital, I'm able to form a sigma bond. However, if I'm able to mix any of these mixed or hybrid orbitals with any of the orbitals, we can also form a sigma bond out of it. So these are all conditions for sigma bond formation. However, when it comes to pi bond, for pi bonds, they are only formed when we have a p orbital. So let's look at this. This is a p orbital with another p orbital. In this case, unlike we said for sigma bond, they are formed from this stage to this stage to that stage, or these are the conditions. For p orbital, it is only formed when there is a side way. A side way means, in this case, there is only one side here. This is p orbital with another p orbital. It is forming only one sideway mixing. So in this case, it is formed when we have p and a p. Take note of this. In pi bond formations, they are only formed when we have a p orbital mixing with a p orbital. What it means is that they cannot be formed when we have a s orbital mixing with a p orbital, just like we form for sigma bonds. So if you are asked to differentiate between sigma bonds and pi bonds, basically with this illustration, then anytime you're asked to differentiate, you can tabulate. So here we can say that it is formed The emphasis here is very clear. With the sigma bond, it is formed as a result of the axial or the head-on overlap of atomic orbitals. Why are we using the word atomic orbitals? We are using the word atomic orbitals because for sigma bonds to be formed, we have about 3 or 4 conditions. It is formed between S and S orbital, that is one orbital, or an S and a P overlap, that is another orbital, and then P and P overlap, that is another orbital. So we prefer to use the word overlap, head-on overlap of atomic orbitals. But do not say that pi bonds are also formed as a result of the sideways or lateral overlap of atomic orbital. No. Here you have to be precise by telling us they are formed as the sideways or lateral overlap of p orbitals. So it is the p orbitals that these pi bonds normally occur. We'll write or demonstrate that with an example for a clearer understanding. We can also say that these sigma bonds, looking at the formation, they are we can say these sigma bonds are localized. What do we mean by they are localized? They are not, their electrons are immovable. They are not able to move. But when you pick the pi bonds, they are delocalized. What it means is that the pi bonds, their electrons are able to move freely. And because of this, the sigma bonds, they are very strong bonds. Okay, they are stronger bonds. And with the pi bonds, they are weaker bonds. We can also say from this concept that these sigma bonds are less reactive. They are less reactive, whilst pi bonds are highly reactive. Having said all this, we can also see from this angle, since they are localized in terms of conduction of electricity, the sigma bonds wouldn't be able to conduct electricity. But these pi bonds, because of their localized or their delocalized electrons, they are able to conduct electricity. Having said all this, I would like you to have these differences in mind. In exams, you can be asked to give the differences between a sigma bond and a pi bond, and these are the conditions. Thank you for watching this video. In my next video, we are going to discuss everything about how these sigma bonds and pi bonds are formed using some molecules. So share the video, comment if you don't understand, and then always stay tuned for new videos. Thank you.